In 9.2 Day 2, we're going to review the infinite geometric series, how you can calculate that from an infinite geometric sequence. So for the warm-up, this is kind of where we left off yesterday. Express 0.36 repeating as a fraction. So the first step is we can write it as a sequence in which the first term is 0.36, the second term is 0.0036, the third term is 0.000036, and so on. So our first term, 0.36, we can figure out our ratio by taking one term and dividing by the one before it. So here it's 0.01. And here's that sum formula from yesterday. If it's infinite geometric and the ratio, the absolute value of the ratio is less than 1, you have u sub 1 over 1 minus the ratio. So let's plug in. Our first term is 0.36 over 1 minus 0.01. That's the same as 0.36 over 0.99. And you can reduce that fraction to 4 over 11. So if you do 4 divided by 11, you'll get 0.36 repeating. The next thing that we looked at yesterday, or one of the things we looked at yesterday, was how to write the sigma notation for each and then to calculate the sum of the series if it has one. So to write the sigma notation, we're going to say, let's add up, this means add up, from the first term to infinity, so we have dot, dot, dot means to infinity. Here's the first term. We need the ratio. Take any number, so 0.2 divided by the one before, which is 0.2. To the n minus 1 power, we have the n minus 1 because we're starting at the first term. So here's the sigma notation. Can we find the sum? We can if the ratio, the absolute value of the ratio is less than 1, and it is. So here's the sum formula, first term over 1 minus the ratio. First term is 5 over 1 minus 0.2. So it's 5 divided by 0.8. And if we do that, we'll get 6.25. So what that means is if we have this list of numbers starting at 5 plus 1 plus 0.2 and see how these approach 0, so we know it's eventually these numbers are getting really small, we can add these together and we can find the sum of the series. Let's try the next one. We'll say our first from the first term to infinity. The first term is 20. The ratio to any number divide by the one before. 80 divided by negative 40 is negative 2 to the n minus 1 power because we start at the first term. Find the sum of the series if it has one. Look at the absolute value of negative 2. Is that less than 1? And no, it's not, so we're going to say there's no sum. And the reason why there's no sum is because these numbers keep getting really big or really small. And so since they don't approach 0, we can't add them together. It's going to keep increasing or decreasing. The next type of problem that we're going to look at today that we didn't look at yesterday was how do you find a missing term? And in algebra, to find a missing term, you plug in everything you know into some kind of formula, and there should be one thing you don't know, and you're going to use algebra to solve that one thing. So let's say the first term of a geometric sequence is negative 10. The sum of the series is 5. Find the common ratio and list the first 4 terms of the sequence. Okay, so we want the formula. Sum is first term over 1 minus the ratio. Let's plug in everything that we know. We know that the first term is negative 10 and the sum is 5. Find the ratio. Okay, let's solve this. I want to get rid of the fraction, so I'm going to put this 5 over 1. I'm going to cross multiply. So we have 5 times 1 minus r equals negative 10. I want to solve for r, so I'm going to divide each side by 5, or you could distribute and solve, but I like to get rid of the 5. So I have 1 minus r equals negative 2. I'm going to subtract 1 from each side. I get negative r equals negative 3. I'll divide each side by negative 1, and I'll get r equals 3. So here, our ratio is 3. Then it says list the first 4 terms of the sequence. So if we list the first 4 terms of the sequence, u sub 1 is negative 10. And then if we multiply, so this one, I'm going to have to double check this because this ratio should be less than 1. So we would say that this is not infinite. Okay, well, I'll do the rule. So the rule is multiply by 3. And so our next one would be negative 30. And that would be negative 90. Negative 1, 9 times 3, negative 270. Yeah, this one though, I'm probably going to have to change this problem because we need a different ratio here. The ratio has to be less than 1 if it's infinite geometric. So let me try this. Yeah, negative 270. Okay, so there would be our first 4 terms. U sub 1, U sub 2, U sub 3, U sub 4. All right, so I will have to change this. Okay. Okay, let's try this one. So this one works. Let me just cross this one off. Okay, so let me make a note. This ratio is greater than 1. All right, so let's just do this one together. So this one shouldn't happen. This ratio should be less than 1. It's not. So let's just do this one. The first term of a geometric sequence is 20. So again, here's our formula. And the sum of the series is 80. So 80 equals 20 over 1 minus r. Find the common ratio and list the first 4 terms of the sequence. So again, I want to cross multiply here. So we get 20 equals 80 times 1 minus r if I cross multiply. I want to get rid of this 80. You can distribute and then solve, but I like to get rid of it first. So we have 20 divided by 80, so 4th, or 0.25, equals 1 minus r. Subtract 1 from each side. We get negative 0.75 equals negative r. Divide each side by negative 1. Let's redo that. So r equals 0.75. This makes sense. Our ratio should be less than 1. Now we can find the first 4 terms of the sequence. So we have 20 as the first term. Now we're going to multiply everything by a ratio times 0.75. So our next term is 15. Our next term is 11.25. And our last term is 8.43. Okay, so here's use of 1. Here's use of 2, use of 3, use of 4. Okay, so that one did work. Let's take a look at, okay, there's 2 types of problems that we're going to look at, a problem with a rebound and a problem without a rebound. So here's the first problem. Kayron drops a basketball from a height of 10 feet. Each time the ball hits the ground, it rebounds to 80% of its previous height. Draw a picture illustrating this situation. Okay, so we have our basketball. It's orange. And first we drop it, and we drop it 10 feet. Okay, so he's climbed up something and it's dropped it 10 feet. Then it does rebound to 80% of its height. So 80% of 10 is 8. So it goes up 8, but it goes down 8. Okay, and then it goes up again to 80% of its height and down. And 80% of 8, we do 8 times 0.8. This is 6.4 feet. And then it goes down again and up again. 6.4 times 0.8 is 512. So again, I'm just multiplying each of these by 0.8. Okay, let's write a sigma notation for the ball dropping and for the ball bouncing back up, then use that to calculate the answer. Okay, so for the ball dropping, the first term is 10. So here's the ball dropping. The first term is 10. Let's write the sigma notation. So for the first term, we get 10. So the first ball drop is 10. And each time it rebounds to 80% of its height, and then we have that n minus 1. And we're going to go to infinity because it keeps going. Okay, so there's the sigma notation for the ball dropping. Now for the ball going up, it has a different starting value. It has a starting value of 8. So for this one, the sigma notation looks like this. Okay, so here the first term is 8. It's still dropping at 80% to the n minus 1 power. All right, we can use our formula that we used yesterday because this ratio is less than 1. So again, here's the formula. I'll write it up here. First term over 1 minus the ratio. So here the first term is 10 over 1 minus the ratio, 1 minus 0.8. Let's calculate that. 10 divided by 0.2, or 1 minus 0.8. This is 50. Okay, so just all the down values adds up to 50 feet. Let's look at when it rebounds, when it goes back up. In this case, the starting value is 8, and we still have the same rebound rate, minus 0.8. And so 8 divided by 0.2 is 40. So what is the total distance up and down that the ball has traveled? We add 50 plus the 40. Okay, there's other ways to do this too. I've looked at doing this formula, so starting here just at the 8 and just doubling this because these each happen twice. So take the 40 and double it and then just add the 10 on. Either way, we'll get 90 feet for how it drops. Okay, so that's if there's a rebound. But let's use the summation formula if there's not a rebound. Let's say a child on a swing is given a big push and she goes 14 feet on the first swing, on the first back and forth swing, but only 3/4 of the way. So here's 14. Okay, so there's 2 ways to do this. 14 feet on the first back and forth swing. Okay, so you can define this 2 ways. There's two ways I'm thinking. We can go back and forth 14, and then we can go back and forth 3/4 of the way, and that would be 10.5, and so on. So in that case, we would double our sum. But the way that I had it written out, Let me erase this. Okay, so we're going to do it that way. So again, she goes back and forth 14 feet. Oh, 14 feet total. Okay, so we're going to say that this total is 14. And we're going to say this total right here is 10.5. And this total right here, and I'm just taking 3/4 or 75% of this, is 7.875. Okay, so here is our list of numbers. And let's write the summation notation. So we're going to start with our first swing. It was at 14, and we're going to keep going. At 75%, we do the n-1 because we start at the first value. Okay, we can use the sum formula, 14 over 1 minus 0.75, and we get a total distance of 56 feet until she stops. Okay, yes, that works. Okay, so with the rebound, we have to add them twice, but this is without the rebound because it's included. The 14 includes the back and forth. So we don't have to write two different equations like we did here. We just need one, and we can use that to calculate. Okay, so this is 9-2 Day 2 looking at that sum formula. Tomorrow we're going to look at one last formula. Okay, so let's quit.